Hello everyone, in this video we'll discuss a numerical on forced vibrations. The question says that there is a refrigerator unit which has a mass of 35 kg and it is supported by 3 springs. Now when any body is supported by springs, that means these springs are in parallel, right? So if let's say the body is being supported in this way, so we see that 3 springs are in parallel and the spring stiffness for all 3 is given, which is S, right? The unit operates at the speed 480 rpm. We have to find the value of stiffness if only shaking force is allowed to be transmitted to the supporting structure, right? Now what happens whenever a body is moving or when a system is operating, a part of force it gets transmitted to the structure or the frame. So we have to find the transmissibility of the force, which is nothing but the ratio of the force transmitted upon the force applied. And the question says that we have to only assume that only the shaking force is transmitted to the supporting structure. Now these are the formulae for transmissibility, right? And we are assuming that, firstly, we are assuming that there is no damper used in the system. So if no damper is used in the system, the epsilon, it becomes 1 upon plus minus 1 minus omega upon omega n square. Now the values that are given is mass, which is 35 kilogram. N is given, which is 480 rpm. So omega is 2 pi n upon 60. We can write it as 16 pi. Now the question says that only 10% of shaking force is allowed. That means the epsilon becomes 0.1, right? And we already know the value of omega. So we can place the value, and this is the equation that we get, and we have to find the value of omega n. Now see, there are two possibilities for this equation to use the positive sign and negative sign. So firstly, we'll try with the positive sign, and when we try with the positive sign, we get an impossible solution. So we tried with the negative sign, and there we get the value of omega n, which is 15.5 radian per second. Now we also know that natural frequency, it can be given by the formula under root S upon m, where S is the spring stiffness and m is the mass of the body. So by placing the value of mass, which is given 35 kilogram, we can find the value of S. Now this S that we got is the equivalent stiffness. That means what do we mean by equivalent stiffness? That I told you that there are 3 springs in parallel. So if we replace all these 3 springs by one single spring, the stiffness of that equivalent or single spring should be equal to this. So because there are 3 springs used, so stiffness of each spring will be 1/3 of the equivalent stiffness, which is 2.679 Newton per mm.